Hello, KringleCon. Oh man, it's awesome to be here. Thank you so much, Mr. Claus, Mrs. Claus, for inviting me to come out and speak to you on software-defined radio, the new awesome. Speaking of awesome, it was really great to come and take the train up here. It was definitely a lifetime of waiting to do something like that, and it was just one of those things that I'm always going to remember. And speaking of something to always remember, I can't wait to tell you all about some of the fun things that I've been doing with some software-defined radio, and some of the just the little things why I think it's so awesome. All right. So a little bit about me. I am a penetration tester and hardware hacker and all sorts of fun stuff at a little company that does pen testing of all sorts of varieties called InGuardians. I'm the director of research there, and this has been some of the things that I've been looking at just for various projects across the board for pen testing and otherwise. I'm also a SANS certified instructor. My primary course is the wireless course, go figure, SEC 617, Ethical Hacking Wireless. I'm also the silent founder and a regular host of Paul's Security Weekly. And I have my extra class ham radio operator, and my call sign is Kilo Bravo 1 Tango November Foxtrot. So if it isn't pretty evident, I have a strong interest in radio of all sorts of varieties, and hence why I'm here to speak to you today about software-defined radio. All right, so let's give you a little bit of background. What is software-defined radio? It's a radio that has no preconceived notion of purpose. We define what the radio does in software. So with various software applications on a computing platform of some variety, whether it be a Raspberry Pi or a laptop, desktop, or some other purpose-built device, we can take a radio and turn it into effectively whatever we want with software. And this has become something that's been wildly popular and has increased in popularity over the last couple of years, just because now the hardware has become so much more accessible to the average user. And we'll talk a little bit about that. That said, because it has become accessible from both a hardware and a project, a software perspective, we now unlocked the ability for us to look at all sorts of new protocols that we hadn't been exposed to before, or from a security perspective, also for lots of fun as well. So thinking about this multitude of software-defined radio stuff that has shown to market and is relatively affordable, I've got a couple of my favorites. There's the Hack RF with transmit and receive at about $300. The Blade RF is about $375, a little bit more with receive and transmit. Arguably one of the industry leaders from Edis, the B200 Mini with receive and transmit at roughly $800. Now we're starting to get a little bit, out of the range of what the CFO will approve, but still really great stuff. Realhowever, one of my absolute favorites is something that's incredibly inexpensive. It's the RTL SDR. A Realtek-based, inexpensive software-defined radio that was originally intended for doing something else entirely. It was only found later that it was an actual sort of mini software-defined radio. A high-quality one with a great kit with all sorts of antennas is about $35. Now, they're receive only, but still, with receive, it gives us the ability to start doing a significant amount of analysis of software-defined radio and radio protocols just from the get-go to even see if this is something we're interested in or if there's something that we need to investigate further and spend more money on. All right, so I think receiving is fun. I'm a computer guy. I like to just sit back and be a wallflower and listen sometimes. And on the radio side, what that really means is I can sit and listen and then find stuff that I didn't know was there before. And then, of course, when I find something that I didn't know was there, I ask myself, what do they do? And what are they there for? And what are they controlling? And what type of information is there? And in some of these cases, you find some very unexpected type of things. So let's talk about some of those things. Now, for me, I like to use some software to discover some signals, and I'm going to show this to you in a little bit, assuming one of my demos doesn't work. But one of the pieces of software that I like to use with my RTL SDR to discover signals, see if there's anything there initially, is an application called GQRX. It is largely cross-platform compatible, meaning I use it natively on my Mac. I use it in a Linux virtual machine. I use it on a Linux box all the time. I'm told that it will run on Windows, but I'm not so much of a Windows guy, so I haven't used it much there, and it's a little bit difficult to install via Pothos and so forth. However, SDR Sharp is very similar on Windows. Gives us the ability to tune our software-defined radio into a station or a frequency, and then we'll visualize what everything is there, so we can see whether there was something present on the airwaves that we can't see with our own eyes. And now it gives us the ability to start drilling down and figuring out where we may want to use. So this is going to use our local software-defined radio to look at local signals. And we can even now start turning this into some stuff worldwide, as there are a number of folks that have taken their software-defined radios in some variety and connected them to the internet, go figure, and allow you to use their software-defined radio. In the case, there's a catalog of them at websdr.org. And one of my favorites is at the University of Twente in the Netherlands, which is here on the slide. But let's take a look at what that actually looks like, assuming, of course, I can get this over to my web browser. All right, and we've connected to the WebSDR at the University of Twente. And I've tuned this to 4625 kilohertz. And this happens to be a fairly famous thing here. We can see in the waterfall display as it goes by. I've zoomed in quite a bit. We're actually listening to the Russian buzzer station, which is allegedly one of those number stations that were used for communicating with spies and so forth. We don't know what the purpose of the buzzer station is, but it's also fairly difficult to hear in many parts of the US, such as where I live, or potentially at the North Pole. So by using one connected remotely to the internet, we can actually extend our range for some of this stuff as well. So this one's pretty neat to listen to, and you can use this from a web browser. It actually plays all sorts of audio. I have this one muted currently. All right, but what else can we do? So we can use the software-defined radio to visualize locally. We can also use some stuff to visualize remotely, such as those listed as WebSDR. And I've also recently successfully used the audio from one of those remotes and piping it through like a virtual audio cable, so we can redirect audio from the web browser to another software application to catch the data. In the case of the one that I was looking at was the ability to do tracking for APRS to a location that I couldn't receive that data locally. Okay, all right, so we looked at the demo of that. I got ahead of myself a little bit there. In any case, there's all sorts of other fun stuff that's available, and lots of it in areas that most people wouldn't necessarily consider. The 433 megahertz ISM band, industrial, scientific, and medical, largely across the world, doesn't require the user to have a license. This is all of your consumer stuff. And there's all sorts of fun stuff in the 433 megahertz range, but we don't necessarily know what it is. However, with the RTL SDR, there is a software package, RTL_433, has done a bunch of community gathered signatures for devices in the environment that they know how to decode. And when they see a signal, we'll attempt to decode it based against the previously matched signals. And some of them are good, some of them are bad, and some of them do lots of false positives. And they have more than 100 devices currently listed. I think my current copy knows how to decode for 113 devices, and about 100 of them are relatively reliable. RTL 433, not only will it decode and give you the output from the stuff that it knows about based on its signatures, it will also give you the generic output that we can do additional analysis with and try to recover and write our own fingerprints for. Okay. So I've used this quite a bit at home. Was head of project that I was going to be working on, and was using it to attempt to connect to my Oregon Scientific weather sensors to populate a weather display. And when I fired that up, I discovered all sorts of other interesting things as well. Some of them that make you ask all sorts of other questions. So let's see what we can see here. And this is going to be a little bit demo that that goes across a couple of things here. Let's see. Let's try to run RTL 433. I was running this earlier and wasn't having a lot of luck. That's because I have this. Now, we mentioned GQRX a little bit earlier, and this is GQRX. I have it tuned to 433.9 megahertz, which is in the 433 megahertz ISM band, which I would expect a bunch of stuff in my environment. And clearly there's some signals here looking at our waterfall display that we see some stuff over time, and the fast forward transform says that there's stuff happening in real time. Now, there's stuff here. I have no idea what it is. I can see that there is stuff here. So if we stop this and I move back over to my terminal session, let's try and see what happens when we run RTL 433. Oh, well, can't open it. Let's unplug it, replug it back in, and try it again. All right, it did fine it this time. It's tuned to 433.92, and I would expect in a minute or two here for stuff to show up. But I tried this earlier with my weather sensor that I brought with me, and it turns out it didn't work so well. I wonder if it's just too cold here at the North Pole. Maybe my device is a little on the cold side and frozen and is not working properly. But you get the idea. Fairly simple command line tool, and we'll start giving us output from all sorts of fun stuff. That's not what I want. I want this one. All right, so we saw some stuff with GQRX. Not so much with RTL 433, given that my weather sensor is probably way too cold here at the North Pole. But we can also do all sorts of other fun stuff with our RTL SDR, such as using something like RTL FM, one of the built-in utilities for the software package, to tune into some radio frequencies and then pipe that outbound to other stuff. And one of those other pieces of software that we can use is a tool called Multimon-NG. And while it's also not just for radio, it will do all sorts of other stuff, such as decoding DTMF for tone dialing, decoding Morse code, all sorts of other fun stuff. It will also do pager traffic, such as POCSAG and Flex. So if we can take the raw audio output from one of our RTL tools, such as RTL FM, and send that via a Linux pipe to Multimon-NG, we can now start decoding any of that pager traffic. Now, be careful where you are, because that may or may not be permissible by law in your jurisdiction. But you can also start doing some research and potentially setting up your own pager transmitters for doing this as well. Okay. So interesting, fun stuff. And there's all sorts of other interesting information for POCSAG and Flex, where it was a protocol that was designed many years ago, where no one thought it was a good idea to have any encryption included there. All right. We've done a bunch of receive-only stuff. And with the RTL SDR, it's a great way to get started in listening. But what if we wanted to do some transmit? Well, there's a couple of ways that we can do so inexpensively with not a lot of great fidelity. We can use a Raspberry Pi to toggle a GPIO ping, and we can use two packages, RPi TX, Raspberry Pi Transmit, or Pi FM for doing FM radio. Those work really well. It can be lots of fun, and we can create all sorts of different transmitter types with that as well. We also have something kind of new that's interesting, is a project called FL2K, which uses some custom drivers for the FL2000 chipset, which are often featured in inexpensive USB 3.0 to VGA adapters, which run under $15 on Amazon. So yeah, we can use a VGA adapter to transmit RF signals, which we can receive with our TLSDR. That's kind of frightening. Now, it's not a great range and it's not the best fidelity, but for 15 bucks, that's kind of priced right and can be lots of fun to experiment with. So there's lots of stuff that can actually be done with FL2K. We can send FM radio, FM modulated signals. We can do some with some of the sample stuff. We can spoof GPS. We can spoof cellular, UMTS, LTE, GSM. We can do digital video. We can do digital audio. We have now a bunch of methods for creating data, which is in the air, which is potentially kind of terrifying. Because what does this really end up meaning is that now we're going to potentially find in our environment all sorts of, quote, rogue transmitters that can be repurposed, just like the FL2000 chipset in those VGA dongles, that we can now do data exfil that is now no longer considered nation state only capabilities. There's a project that my intern and I worked on called Vapor Trail that uses a Raspberry Pi to do just those same types of transmissions that would have been previously considered nation state only capability. And if you're really scared about some of this type of stuff, Dragos has some stuff that he's been working on and analyzing RF-based transmissions coming out of all sorts of various things that are probably either in your home or enterprise, such as keyboards, motherboards, USB drives, all sorts of things that are now, quote, unintentional transmitters. Okay. So what next for all of this type of stuff? What does this really mean that we can have inexpensive transmitters and even inexpensive receivers? What does it really mean for data exfiltration for both a pen test with command and control or with some other malicious actor for command and control? Can they now go out of band that you don't have the ability to detect with your traditional tools? So now we need to sort of step up our game and do additional RF detection programs to start hunting some of this stuff down, because now this is just no longer a pipe dream of the paranoid. It's allegedly happening, and the tool set is becoming more and more robust to make this happen, to take all of this stuff out of band. So with this, we're just scratching the surface. I'm probably about over time. We have so much that we can explore with software-defined radio. We have so much that we can interact with. And what ones are we finding that that leak information from our environment that may be considered information that we don't want out? And then how can an attacker interact with that to potentially change our environment or use that as part of information for some other part of an engagement or some other attack? Okay, so with that, software-defined radio has opened up so much more of this wireless spectrum for both attackers and for us as security professionals to use and to be concerned about. So with that, again, thank you to the Clauses for bringing me here to the North Pole. It's greatly appreciated. It's been great talking with you for this time, and I do hope that you do enjoy the rest of your con. Stay warm, and if there are any questions, don't hesitate to reach out, and I'd be happy to follow up and talk to you about some software-defined radio stuff. Thanks again.